Hello, I'm going to do a quick overview of my home-built precision 10-volt reference using an LTZ1000A ovenized Zener. This is the enclosure, self-contained battery, 10 amp hour of 5S LiPo battery, some monitoring, some control, ovenized. I have an oven for the LTZ1000 board and also the 7 to 10 volt buffer board, and I'll take it apart and I'll show you here in a second. But just a real quick operation. I don't have the labels on it yet. I just did test assembly and put everything inside basically to see how it all fit. Make sure it still fits while building it. It's a good thing. And wanted to do a quick video. So here we have power switch, which turns on the 10 volt, or sorry, the 15 volt regulated DC for the LTZ1000 and the voltage buffer boards. Going to be using, I don't have the 10 volt buffer board built yet. I'm waiting for the VHP resistors from Vishay to arrive. That way I order the correct value resistors for the voltage buffer. I'm going to be using an LT1010 buffer driven by an LTC1150 op amp when the parts arrive from Vishay. So anyways, we have our 15 volts on, which allows me to engage or turn on the heater. So this is the heater for the oven, and of course you turn master power off, it shows them both off. This LED in the center is external power. Right now it's running on internal battery power, but I have jacks on the back for external power. So I have external power and then guard, and then this DB9 is actually going to be used for a charging header for the batteries. So what I'll do is, up here I'll turn on 20 volts. I have a board inside that will automatically take and switch to external power when it sees 20 volts. I built it to where if I turn this off, it will always show external power. I turn the 20 volts external off. You see it goes away, and it switches back to its internal battery. Voltmeter is always going to show the available voltage. I'll turn on external power again. Now, one thing I did was I tried to make it somewhat foolproof. So if you plug in or connect too much voltage or too little voltage, it will automatically just switch over back to internal battery voltage. So right now I have it 20 volts in. You see that, 20 volts. Now I'm going to lower it down to 18 volts. You see it switches off of external power and switches to internal. Bring it back up. There's 19 volts in. It takes external power, 18 volts back to internal. So it takes 20 volts in external plus or minus 2 volts. Now if I go up to 21 volts, still on external power, 22 volts is still external power, 23 it drops out. And back to 22 and 23. So I also have reverse polarity protection built into it. So this is also handy if you want to run external power to run the reference on all the time. But let's say you have a power outage, no big deal. You have a power outage, we turn our output off, it switches to the internal battery, and the reference alone draws about 25 milliamps. And with the 10 amp hour battery, that will give you, well, a week's worth of operation before the battery will get low. And this LED over here will flash. It's a red flashing LED when the battery starts to get low. So let's see. I just got done installing. These are genuine Pomona 3770 trillium copper gold-plated low thermal EMF binding posts for the reference output, just to help with any thermal EMF. And I'll take the cover off of the box here. It's all completely portable, which one of the things I wanted. Okay, so I'll plug the power. I'm going to set the phone down for a second so I can get the top off. Let me see if I can. Hold on one second. There we go. Had to lift up here a little bit. And then pull this back. Hard to do with one hand. Okay, now I have to have my guard. I have to disconnect real quick and then pull the lid aside. There we go. Okay, so we have two 5S 5000 milliamp or 5 amp hour battery packs. I don't have this wiring over here straightened out quite yet. I have a board coming, a protection and LiPo monitoring board that will automatically disconnect the batteries if there's a problem with any cell, or if the voltage is too high, the charge current's too high, charge voltage is too high, cell voltage is too low, whatever, it will automatically disconnect. So that board's not in yet, should be here today or tomorrow. I'll get that part done. This is a foam insulated die-cast aluminum box for the oven. Let me pull the screws out for that. I'll show you what's inside. And over here, while I'm unscrewing this, that's my input switching and protection circuitry. And then down here I have the 15 volt LDO regulator and oven control circuit. Let's see your other features. You can see some of the wiring for the front panel. And I've tested the oven stability to be well within 0.1 degrees Celsius, and I have it set for 35 degrees Celsius or about 95 degrees Fahrenheit. Should do it. Oh, got one, needs a little more. There we go, and this is the die cast top. And inside the oven, let's see, let me grab one of the KX reference boards to show you how it mounts inside there. This is my reference up here, by the way, just cooking away. I just have some cheap 1/4 watt resistors on it right now, and which is fine for just burn-in. When I first plugged it in, it was 7.13368 volts. It's still 7.1336768, depending on temperature of the 34465 meter. The LTZ1000 is more, even with the cheap resistors, it's more stable than the LM399 based reference and the Temco of the Keysight 34465. So here's one of the boards. It'll fit in here like so, in those brackets. And then here's my 15 volt power, which I'm going to run over to this board, put some more input filtering on the DC power, and then over to the KX reference board. Then it's going to jumper over to this board, which is going to have my buffer circuit built on, and then the 10 volt buffered output. This is a Teflon twisted pair solid wire, which then feeds to the front terminal jacks. Here's just a cheap, put a little cheap temp sensor, LCD display on there to measure the internal air temp. I'm using a 1% precision NTC 10,000 ohm resistor, which I played around with trying to find the best position to give me the most stability and the most accurate temperature. And I ended up using some thermal epoxy and placing it just off center from here. I have two 25 ohm 10 watt resistors bolted to the aluminum enclosure, one over here and one on the other side. And I found that if you move the thermistor or the 10K thermistor too far away from the heating elements, you end up with an oscillation. There's a thermal delay between as the temperature gradient makes its way over to the thermistor, and you end up with this cycling oscillation. So in order to get the most consistent temperature and without oscillation, I found placing an offset about an inch was the best. And let's see here. So still waiting. And once I have the precision foil resistors from Vichy for the KX board, then I'll be able to mount it. And then once I have it mounted in here and I can figure the exact ratio I need for the buffer, then I'll order some more Vichy precision foils for the buffer and build that. Then I'll have my 10 volt output. But it's coming along. Still got a little ways to go. Can't wait for the resistors to get here. Should be here in the next week or two. And that's about it. It's coming along pretty good. Thanks. Bye.